So e to the x, its derivative is itself. However, if you've got something other than just an x and the exponent, you must also multiply by the derivative of the exponent, which means the derivative of e to the 2x would be what? 2e to the 2x. What is the derivative of ln x? 1 over x, and if something is in the ln that is not just an x, you have to do u prime over u. Okay? Then we also did the integrations. The integration of e to the x is also itself. However, if there's something in the exponent, how did we do that when we were working backwards integrating with the 2? Huh?
Divide by the derivative.
Yep, divide by it. So you can put e to the 2x over 2, or you can put a 1/2 out front, the reciprocal, either one. And if you're integrating 1 over x, it becomes the ln of the absolute value of x. U prime over u becomes ln of absolute value of u, provided there wasn't something else. Working through the log stuff, we did have lots of log rules that we used from like pre-calc and algebra 2. Like ln of a plus ln of b condenses to be ln of a times b. Ln of a minus ln of b becomes ln of a divided by b. And I did not give myself enough room for a fraction. What can we do with the exponent on the, so that becomes n times the ln of x.
And does that have to be brought up?
It doesn't have to. It just helps you sometimes to simplify. If I was taking the derivative, I'd much rather take the derivative of a number times the ln than something taken to a power. Yep. Ln of 1 we all know is what? 0. Ln of e is 1. And ln of e to the x is x. This formula from this showed up on our practice exam. Do we remember that one?
1 over x prime of x to the negative 1. I asked you about it just before.
That was the only one of these weird formulas that showed up on the exam. And that is not uncommon. So this one, I would pretty much bank on it showing up one time. It was, I think, in a multiple choice. But I don't know if I would bank on the other trig formulas showing up. I feel like at some point I would just kind of cut my losses and move forward in life, okay? Separation of variables, you can only separate using multiplication or division. So you either have to multiply or divide by the x and y pieces to get it to the other side. So for something like dy dx equals 6x squared minus 3x squared y, I cannot currently separate my variables because I can't add and subtract the y. So how would I have to fix that or help myself out? Factor. Factoring is always the answer. What can I factor out? I can take a 3x squared out, which would leave me 2 minus y, which then allows me to divide. If I divide, then I can have my 1 over 2 minus y dy equals 3x squared dx, and then integrate both sides with respect to each piece. This did not show up on our practice stuff, did it? Nope. This is pretty common, though. So, yeah, should have. We would have known it, okay? And I'm not going to finish solving that out, but just remember you have to separate by multiplication and division. Okay? Sometimes if the variables are not x and y, you have to recognize which one's the x and which one's the y. So in this case, the p is acting like the y, and the t is acting like the x because we're used to dy dx, and it's dp dt. So in this case, I would divide the p plus 2 over. That would give me 1 over p plus 2 dp equals 100 dt, and then integrate. Okay. And is that all of our? Not very much to talk about today. So, good day summary for chapter 5. It is. Look at that.